Lesson 11.8 is called scatter plots, and a scatter plot is literally just plotting some points and they're going to be scattered all over. So it wants us to create a table using the data here, and so they give you an x and a y. This is a coordinate point like 9, 8, and so I just want you to plot those. Remember that it goes x, y, so you go right 9, up 8. This point would be 5, 8, right 5, up 8, and go ahead and graph the rest of the points. And it would look like that. Then what I want you to do is pretend that you're trying to draw a line through the middle of the points where you want the same amount of points above and below the line. Kind of just eye it and see where you think the trend of the points are going. Something like that would be good. And that's called a line of best fit. Line of best fit, because it's best fitting through the data. So this scatter plot shows some kind of correlation. A correlation is like a pattern or some kind of connection between the x and y, and it goes along with slope. So it looks like as x's are increasing, y's are increasing, or this has positive slope, so we say it has positive correlation. Because as the plotted values of x get bigger, the y's are also getting bigger or increasing. Okay, go to the next page. Okay, then you'll see that I just went ahead and put some pictures on here for you so you can see the different types of correlation. Here's positive linear correlation because it's making positive slope. It says with an outlier. This point right here is called an outlier because it lies outside of the normal data. So sometimes you'll have one, sometimes you won't. And then we have nonlinear correlation, obviously because these points are not in a straight line. They're actually making an upside down parabola, so that'd be a quadratic kind of correlation. We have negative correlation because that's forming negative slope. We don't have an outlier, but if you had a point out here, you would say with an outlier. And then no correlation means there's no trend here. I couldn't make a line of best fit because the points are so scattered. Number 2. These will be multiple choice, so it'll make it a lot easier than us coming up with the answers. But it says, Allison has a part-time job at an ice skating rink selling hot cocoa. She decided to plot the number of hot cocoa she sold relative to the day's temperature, and then draw the line of best fit. So this is her graph. Oh, what is the line's y-intercept? A y-intercept is the point on the graph where the line touches, crosses through. So the y-intercept is right here. That means that this point has an x value of 0. It's 0, I don't know, what do you think that is, 118 maybe? So again, this is a line of best fit. We can't say that this is an exact number of cocos that she sold. We don't really know, but it's an estimate. When the temperature, because that's our x value, when a temperature was 0 degrees, she sold about 118 hot cocos. Okay, and then part B, it says, what does the slope of the line? Slope, remembers the letter M. It is the rise to the run, and rise is just the y values, or change. You can use delta. This is a triangle, but it's delta y, change in y over change in x. What are y's doing as x's are doing something? Well, it looks like y's are going down, they're decreasing, right? And then x's are going to the right. So that's making a negative slope. But what's changing is it's as the she sold less hot cocos as the temperature changes. So I would say something like this. The average change in hot cocos sold as the temperature decreases. It could even be 1 degree. Or per 1 degree. That's the temp degrees is per 1 degree. So every time it drops a degree, how many did she sell? Every time it drops a degree, how many did she sell? Again, these are going to be multiple choice, so you'll notice which one it is.